Wow, thank you everyone. I'm Jacob Torrey. There's probably more people in this room than there are in my entire town. So it's been a great start to the morning. I couldn't have asked for a better keynote to prep for my talk because we did touch on adversary in the middle phishing. And that's what I'm going to be talking about, specifically how to detect and stop that in Azure environments even before the user types in their password. While I may be the one person on stage you see, there's a lot of people standing behind me supporting this research that couldn't make it out. Some of you who have been to Blue Hats in the past may recognize Casey, aka Sub T. He's spoken in both the most recent one in October in Seattle, as well as in Israel in years past. So there's a large team behind me supporting this research. Just want to make sure I give a shout out to them. And we'll move on now, looking at who I am and some of the things that we do. So I'm the head of labs for ThinkstCanary. We're a deception company. Labs is our research group within Thinkst. One thing that I want to give a plug for, and it is free, and so I'm allowed to do that here. Every quarter, I go through thousands of blogs, talks, papers, presentations in the information security community, covering on average 4 conferences every day. And we go and look for things that either are brand new, kind of cutting edge research, or things where we're starting to see momentum coalescing from different research groups around the world. And every quarter we release a free publication called Thinkscapes. We give it away for free. It's a lot of work. I would appreciate it if you all enjoyed it. I think it's a great read, and it helps you keep track of all the things that are going on in the information security world and landscape and what's coming next. So with the shameless plug out of the way, we can move on to this talk. So this is the thesis slide. This is hopefully the hook. This is what will either you'll be the one thing you remember from the talk. That's great. Then you guys can go back to your phones after that. But the main thing I want to get across is deception engineering is really hard, especially with fragmented environments that are on the cloud, on premises, partially run by software as a service vendors from other organizations. It's really tough, and it's getting more difficult with the SaaSification of business critical infrastructure. And so now organizations are being blinded. Not only are they trusting a third party with their business critical information and processing, they're also in many cases losing visibility. And here I have a slide from the Microsoft shared responsibility model. And you'll see that identity and directory infrastructure is that seam where the vendor and the organization or the customer, they have a shared responsibility. And that seam is where attackers are going after, because there's a little bit of, I'm not sure if this is my responsibility or not. And so attackers are exploiting this seam. And today we're going to look at a new canary token that provides visibility into that seam specifically for Azure and all the Entra ID services. And our goal really is, in this case, is to take this thesis and instantiate it into one easy-to-use, free sensor that provides visibility into Azure phishing. Catch the attackers before they log in and get entrenched in your environment. Save your nights and weekends from doing painful IR and trying to evict attackers before they even get there. And so that's really what today is about. So we're going to be kind of zooming in from this big thesis of the challenges of losing visibility with SaaS environments and more third-party vendors in your environment to look specifically at Azure. Now, some of you may know what canary tokens are. Some of you may not. Essentially, in the deception world, we think that by providing lots of lightweight, fake information or deceptive information, we can flip the asymmetry to put more cognitive load and more challenges back onto the attackers. You hear the adage, which we can always debate, of attackers only need to win once and defenders need to win every time. We can flip that around with deception. By putting the cognitive burden back on the attackers, we can slow them down, we can increase their risk, and we can reduce the value of the things that they are going for. And so canary tokens are files, data, credentials They're also known as honey data, honey tokens, and they alert whenever they're used. And so you can essentially create unlimited of these for free. You can mine your environment with these, and you get really great kind of network motion sensors where you can then locate when someone is moving around in your environment when they shouldn't. And that helps you localize breaches. So they're free online, canarytokens.org. It's all open source. You can host your own environment if you so choose. So I have 2 quick demos just to get the gist of it. They're pretty straightforward. The first one, Microsoft Word, is just a file-based token. You open a Word document, and it alerts. And then the second one is Azure Service Principal credentials. As we saw from the keynote, attackers think that Service Principal logins are pretty juicy. And so if an attacker's in your environment and they come across credentials for a Service Principal, they may want to try to use it. So real quick, kind of on the right side, you'll see me triggering the token. So in this case, I'll be opening a Word document. And then the Canary Tokens console just basically shows the alerts. And so again, this is something that you can do right now on your phone at canarytokens.org if you'd like to create one of these, or throughout the day. So it's hard to read, but I have a file on my work computer called private, and I have some information that's kind of my passwords and my tax information, or so they think. And the moment that I open that file, and this could be run on the attacker's system, this could be run on my system, I'll get a high-quality alert that something has happened. I'll get the user that opened the file, the IP address that opened the file, and very quickly I'm able to then start geolocating both within my network as well as within the world of where this adversary is accessing my data from. So quite straightforward. Here's the same thing. This is just me logging in. So when you go and create an Azure login token, you essentially get a credential, not for your tenant, so you're not exposing yourself to any risk. And you get the credentials in a JSON file for how to configure it. And you see I'm going to log into that tenant with this service principal information. And then the same thing on the side, you'll see, oh, this principal was used. It was stored on Jacob's laptop. Let's all be worried and go tell Jacob to unplug his laptop and start incident response. So that's kind of how they work in a nutshell. I really do encourage you all to play with them. They're a lot of fun. When we think about Canary tokens, especially evaluating how to build a new one, we kind of have these multiple axes. We kind of the Tau of Canary tokens, and we have these radar charts that help us think about maybe where we have gaps in our offerings and how we can improve, right? So we want them to be as indistinguishable to an attacker as a real thing. So in this case, it is a real Word file, or they are real service principal logins, so that's great. How easy is it for the attacker to use? Do they need to install proprietary software? Do they need to whitelist certain IP addresses? In that case, not so great. Does the attacker need to be online? So the Word one, not so much. I could be offline, and maybe I'm worried about these types of things, and so I will disconnect my computer from the internet, open them up, and now nothing will alert. It's pretty difficult to connect to the cloud when you're not online, so in that case, the Azure token does pretty well. How excited would an attacker be? As a red teamer, when you're moving through a network, if you see credentials for cloud infrastructure, you're pretty darn excited. You're like, I want to know what's behind there. I want to jump to the next part of this. How do they find it? And then lastly, how easy is it to deploy? Is it very difficult? Is it something that you can just drop and forget about? Because again, we want to shift the cognitive load from the defender back to the attacker. And then our last piece of background, which is very conveniently, I think the same kind of basic figure also from Microsoft, adversary in the middle phishing. So we already went over this a little bit this morning. It's kind of the evolution of phishing, right? So for a while, phishing was kind of boring and not in vogue, and now it's coming back with this kind of release and democratization of adversary in the middle phishing. So rather than just cloning the front end of a site and hosting it statically, trying to catch username and password, now you sit in the middle as an adversary, reverse proxying, and being able to handle most MFAs, being able to kind of steal that session and then use that to further your access. And there's massive growth in this. 50% year-over-year growth in the last couple of years, and it's only gone up. An IR firm, Kroll, reported that in 90% of their investigations of compromised Office 365 environments, MFA was in place, but sessions were still stolen through things like this adversary in the middle phishing. So I wanted to think about how I could build a canary token, again, to provide visibility in that seam between customer and provider responsibility. So could we provide a lightweight sensor that provides alerts on this detected badness? And I thought that the login.microsoft online website is a perfect place to be able to protect, because it gets phished a lot, because everyone goes there to start their day in the morning, they log in, and it's one of those challenging environments, right? Because Microsoft doesn't have all of the context of a tenant owner. Maybe they want lots of Eastern European groups to log in at certain points in time. And then the tenant owner doesn't see the raw telemetry that Microsoft sees. So they both are kind of operating at a slight loss disadvantage. And so this canary token that we're going to show today kind of is one small step towards improving that visibility, letting the tenant owner see that telemetry in real time and to be able to kind of work on catching that. And so I also want to hint that we're still working on what cloud native deception is, just as a little teaser for going on, and I'd love to chat with you throughout the conference about what you think that may look like. So could we instrument Entra ID to alert on a phishing attempt that's performed by adversary-in-the-middle phishing? We've been doing this for almost 10 years now, and of the tokens, some kind of have their peak. Log4j was very, very popular for a few months. We have a Log4j token, and now it's kind of not used very much. One of the most durable tokens on the Canary Tokens website is the cloned website token. It's very simple. You give it your website you want to protect, so jacobtorrey.com. It generates a snippet of JavaScript that you add to your website, and then every time someone goes there, it checks, am I connecting from jacobtorrey.com? If not, let me load an image from a Canary Token server, and now I know where it's being loaded from and who is it being loaded by. And so that was a great solution, but we're starting to see with more of these SaaS environments that, fortunately, they don't let you run and write arbitrary JavaScript to your login pages. That would be atrocious. So fortunately, we don't have that problem. However, we now can't use this same token to provide the same capability that we're really looking for. So we had to look what primitives are available to change. Specifically on Entra ID, we found the company branding option, which is the organizational branding is the name in Microsoft Graph API. And it allows you to basically put cat pictures as your login background. You can put custom text in certain areas. You can change the language based on locale. But most juicy for us is that you get custom CSS. So you can upload your own CSS. Now, obviously, CSS isn't quite as powerful as JavaScript. But with a little bit of CSS, now we start to have this primitive we can start building off of, right? So if you can customize your login page and add some of it, now you might be able to build something. And so that's where we were kind of stuck. I looked at trying to create side channels in CSS to be able to, figure out if someone was on the right page, not going down that route. We did find that in the CSS, actually the body element on the login page is completely covered, so we could do whatever we want. If you can sprinkle in a little bit of CSS, fetch something from a server or a serverless URL, now can you start to figure out, at least you get the telemetry, you can see who's connecting, you can start to see what their environment might look like. Conveniently also for us as outsiders, not as Microsoft, the Entra login page actually sets a refer policy. So it instructs all browsers that are logging in to communicate with all of the sites that are being referenced that it wants to have a refer. I really apologize. I'm not sure why this is automatically rolling. And so with that, now if our function is going to check the refer, do we get a refer from a Microsoft domain, or is this something that is coming from somewhere else? So as this is very clearly excited to show you, this is the happy case, right? So I'm a user, I log into Entra ID, it comes back with the custom CSS. Maybe it's got some cat pictures, maybe it's got something else. It also includes a hidden image URL that then goes out to our serverless function on AWS CloudFront, but it could be Azure, it could be anything. And then it checks the refer set to make sure that it's coming from a Microsoft domain. Pretty straightforward. In the happy case, that's all it gets. It gets a transparent one-by-one GIF or GIF. Unhappy case, so we talked about earlier a paid version of a adversary in the middle phishing kit. Evil Jinx is an open source one, so if you don't have $1,000 to go and commit crime, this one's free on GitHub. And so in this case, if you are phished through Evil Jinx, you click on a lure or you somehow get kind of co-opted into clicking onto this, you go to that adversary in the middle proxy. Now, they want to let you load that CSS from Azure because it may have your company logo or your cat picture that you really want to show. And so they have to kind of allow that, otherwise you'd be kind of suspicious of why I'm logging into my Thinkst environment and it's not the right color and it doesn't have the right pictures. So that CSS will go, and then it will fetch kind of directly from the browser back to our serverless function, not going through that proxy, because the proxy is only for certain URLs. That phishlet is configured to only proxy certain URLs, as long as they haven't specifically done all of our AWS, which looks like a CDN. In that case, it checks the referrer actually doesn't match now. It's coming from evil.com, not login.microsoft.com. And Microsoft doesn't own evil.com, at least last time I checked. And so now it will actually send you a redirect to go to our Canary token server, passing along what server you connected from, what your client IP address is, where you are, all that information, which can then help an attacker, or sorry, a defender, go in and start to triage that and action that alert. So looking at it here across these axes we talked about earlier, it's pretty difficult to find because you would need to go in, especially if you're blasting this out to a lot of people, you would need to go in and enter and manually review the CSS for every possible tenant that you're looking at because it's loaded after you entered the URL, the email address. And attacker ease of use, it's really easy to use because it's seamless. Connectivity, last time I checked, the cloud is on the internet, so yes, the attacker has to be online. Excitability, I think the stats speak for themselves. They are already doing this, so I think they're going to be happy to continue doing this. And then the discoverability, I mean, this is a feature built in by Microsoft. It's used by our enterprises. It's not something that is, you know, they need to go in and kind of find some small menu for. And it's a couple of buttons to click to deploy. So it's very straightforward. So let's take a look in action. We're going to start off looking from the attacker view. And so this is going to be setting up Evil Jinx. So you download it, you download the phishlet, or which is kind of the configuration for basically phishing Microsoft. It will generate a unique lure. So what it doesn't want to do is it doesn't want the root of the server to expose that it's a phishing site, because anytime there's a new site listed online, a bunch of bots go and check, does this look like a phishing site? If so, it will lock it down. And so if you go to the root domain, it kind of says nothing, but there's a unique key. And so say it looks like I'm logging into Microsoft. You'll see on the web developer console on the right, it's basically going to be monitoring for network activity. So now you got the sign-in page. So we're phishing Microsoft right here. We have a sample user on a test tenant that we're trying to attack. They log in by putting in their email address. They click next, and you'll see the very exciting background picture as a cat picture. But you'll notice that it's actually already fetched a URL from Canary token. At this point, before the user has even typed their username, the defender has gotten an alert saying, this URL has phished this IP address at this time. We got you. This can go to webhook, this can go to Sentinel, this can go to Splunk, whatever you want. Basically, we've caught you right now. So we've deployed this since February 1, I think, was when we rolled it out. And this is one of our first tokens where we kind of get to see all the data, right? Because the serverless function is called both when something bad happens as well as when something benign happens. And so it's been kind of interesting for us. This is my first foray into seeing live threat data and kind of understanding, you know, I was shocked, honestly. These kits are very temperamental. They're very protective because they don't want to have their infrastructure burned down. We've seen one guy kind of going across multiple tenants, you know, phishing across multiple users, you know, and these things are out there for a long time. So this is pretty exciting for me. It's pretty popular. We've had random tenants join, so Canary tokens is free. We don't have any client-customer relationship with them, and so the data that you'll see here is just from that. We do have about this same amount using the professional version, which is not included in here. And so it was pretty humbling to me to put out a blog post and a tool online that when you click accept, you're essentially giving admin privileges just for a second for us to call some Graph API calls and change the organizational branding on your environment. And some of these tenants have millions of logins per week. So they're pretty large organizations. This data I grabbed from about a month ago, so it's gone up, continued to go up there, and you can see most people don't work on the weekends. So that's not the most interesting data right there, but you're starting to see, we're actually alerting about a dozen-ish unique domains every day. This is again about a month old. We've reported over 200 unique domains. These have been reported to MSRC as bad sites because they are phishing Azure. Obviously, some of these look like blue teams, so login.fake.com I'm not too worried about. Some of them don't actually exist. It's just someone who is spoofing the refer. Perhaps unsurprisingly, attackers are cheap, just like me, and so they use Let's Encrypt when they're setting up their SSL certificates because they want that little lock icon in the corner, but they don't want to pay for it. What's more interesting here actually is just how quick we are seeing this. So about a third of our alerts that we detect, the SSL certificate, or TLS certificate, was issued within 24 hours of us finding it. So we are seeing these adversaries the day they are setting up their infrastructure. Probably they are there testing it. Does it work? And then they burn their infrastructure. We report it to MSRC, and I'm sure they go and happily blacklist that domain. Our median income across all of it, we're talking about less than a week from when the SSL certificate was issued to when we're alerting and telling the tenant owner, this is a bad domain, block it, and move on. Even looking at domain registration, still about 1/6 of the time, we're detecting it in the first day. There are some outliers. These are definitely sites taken over. There's a small karate website from the Midwest. That website obviously got hijacked. It has a new SSL certificate, and now it's a phishing site, but it's been around for 328 or whatever days. So this is not a silver bullet. I'm sorry. We still have jobs. Adversaries adapt, right? So there are red teamers that recognize the risks of the refer header. There's a blog that came out just last week about setting a CSP or a content security policy header on your phishing site to deny access to non-Microsoft URLs. We also don't alert on a blank refer. For one hand, it's less information. You don't know who's phishing you. And also, we didn't really know how noisy that would be. We could change that behavior very easily because Microsoft does set a refer policy, so it is expected. We only see about 0.1% have a blank refer. Those could be strangely configured browsers. They could be malicious. They could just be some strange, otherwise proxying environment. And also sometimes we see alerts that are actually the good guys. So Microsoft Smart Screen has a bunch of tools that go out and monitor these phishing sites to say, should we still block those in Microsoft Edge? Should we still block those environments? And so some of these alerts are basically the good guys checking up to make sure that they're still there. And as we mentioned earlier in the keynote, Band-Aid shouldn't stop the gold standard, right? So authentication really should be pushing phishing-resistant MFA. I set up a new tenant a couple months ago, and it told me to install the Microsoft Authenticator app and get the TOTP. It would be amazing now that you guys have passkeys to say, here, install a passkey, integrate with Windows Hello. Do that before you push for something that's going to be phishable. I think that's really what I'm calling on all the builders to think about. Another thing is that conditional access policies shouldn't require disabling the amazing kind of standard security suite that comes when you create a new tenant. Tenant owners should be able to have both. I may not know how to create a comprehensive set of conditional access policies. I might just know that I don't want to have XYZ regions connecting to my tenant. And so I'd like to be able to have both. Coming back to that thesis, more visibility in more places, right? So Canary tokens provide that visibility, in this case, into that seam between customer-owned, customer responsibility, vendor-owned, vendor responsibility. They are great. They have low false positives. But you think about it, this has happened a lot of places, right? The move to the cloud was a huge leap. It was kind of evened out a little bit. Early on, it was infrastructure as a service. So it was my servers or my VM workloads running on someone else's server. And then it moved to kind of platform as a service. So I gave up a lot, which is great. I'd much rather have professionals managing some of my platforms. And now we have software as a service. And I think that federated identity, especially in the cloud, is the core target, and it is the asset to protect. And so it was great to see the keynote today talking about cutting those edges in a graph to make sure that identity doesn't let you move through an environment. I also want to pose a question to the community of what does an identity token look like? So Auth0 does actually have a honey user concept, so you can actually run JavaScript during the login process. So you can create users that don't actually exist in your IDP, and then you can alert on their use. We're working on kind of a broader Canary IDP concept, but I'd love to work with the community here to think about how would you add deception to federated identity. And then lastly, builders who are in this room of SaaS products need to consider that not only are you being trusted with workloads and data, you're also sometimes blinding your customers a little bit to what's happening in their environment, and you're creating these gaps where attackers can kind of live and exploit the fact that the provider may not have the full picture and the customer doesn't have the full telemetry. So at these seams, it's really important to make sure that we optimize and provide that visibility. So in conclusion, Entra ID is a really popular phishing target because everyone uses it, and it's how you get on the internet, pretty much. And these tools are making it super easy to steal sessions, hijack them, even with most MFA capabilities. SaaS outsourcing kind of reduces that visibility, making detection engineering that much harder. The Entra ID token offers a sensor to hopefully kind of help provide more visibility at that seam. Again, it's free Canary tokens. It's gaining popularity. The more people using it, the more data we have on attackers, and the faster we can shut them down, which I love. I think it's great to be burning down attacker infrastructure. The day they create it, they can pay for all those domains if they want. I think we still need to move people away from phishable credentials. That's the goal we all got to be working for. Consider visibility when you are building things. And with that, thank you very much. I will be at the Q&A, the end, to answer any questions. And then there's a QR code both for the ThinkScapes as well as free Canary tokens. So thank you very much.